Hello, this is Miss Moore, and today during chemistry we're going to discuss calculating pH. Today's essential question: what is pH and how is it measured? For today's lecture, you're going to need your calculators handy. And another quick review on acids and bases. Acids are hydrogen ion donors, meaning they release hydrogen ions in solution. And when they release hydrogen ions, they hook up with the water and produce hydronium. So you can think of acids also as hydronium ion producers. Okay, bases are hydrogen ion acceptors, meaning they gain hydrogen ions in solution. What is pH? pH is the measure of the amount of H plus ions in solution. It can also be a measure of the amount of H3O plus ions in solutions. Because again, when you put an acid in water, the acid releases an H, which hooks up with an H2O to make H3O. So for this discussion, H plus and H3 plus, the amounts are interchangeable. Okay. So the greater the amount of H plus ions or H3O plus ions in solution, the more acidic the solution. A basic solutions would have lower concentrations of H plus or H3O plus ions in solution. Okay, and let's do a really quick review on the pH scale. Remember that pH scale ranges from 0 to 14, and that a neutral solution, which means it's not acidic or basic, would have a pH of 7. Acidic solutions have pH of less than 7, so 0 to 6 or something. And the smaller the number, the more acidic. So something with a pH of 1 is very acidic, where something with a pH of 6 is not so acidic. Basic solutions have a pH of greater than 7. The larger the number, the more basic. So something with a pH of 14 is very, very basic. So again, neutral solutions have a pH of 7. And as you move away from 7, if you move lower than 7, you get acidic solutions and they become more and more acidic the farther you get from 7. And if you move above 7, you get basic solutions, and the farther you get from 7, the more basic. Okay, calculating the H plus or H3O concentration. When an acid is added to water, an H plus ion is released, creating a hydronium or H3O ion. When a base is added to water, an H plus ion is taken from water, creating hydroxide or OH1 minus. The concentrations of H3O and OH in any solution is always 1 times 10 to the negative 14th, always. So that leads us to this formula here. The concentration, remember the brackets here? Brackets mean concentration of something, okay? So the concentration of H3O times the concentration of OH in any solution equals 1 times 10 to the negative 14th, which means if you know the concentration of either H3O or OH, you can calculate the concentration of the other one. So now let's try that. Okay, so for practice, if the concentration of H3O in blood, so H3O is 6.5 times 10 to the negative 9, we want to know the concentration of OH. Well, we've got that formula, concentration of H3O, or H plus, either way, times the concentration of OH equals 1 times 10 to the negative 14th. Be best if I knew how to write, negative 14th. All right, so now we just plug in what we know. We know the concentration of H3O is 6.54 times 10 to the negative 9th. We're trying to find out the concentration of OH. and those multiplied together always equal 1 times 10 to the negative 14th. So to solve for OH, which is our x, we'll divide both sides by 6.54 times 10 to the negative 9th. And that gives us an OH concentration of 1.52905, etc., times 10 to the negative 6th. Right, and if we go back and try to figure out our sig figs, because this is a given, because this is a constant, it's always true, we'll ignore that number. We'll just look at our given here. And that has 3 sig figs, so we'll keep these 3. So our final answer will be 1.53 times 10 to the negative 6th. Not too bad. Now let's talk about calculating pH. pH is the negative logarithm of the hydronium ion concentration. And the formula for pH is pH equals negative log of the concentration of H plus, or pH equals the negative log concentration H3O plus. Remember, in this case, H plus and H3O plus are interchangeable because an acid loses an H when it's put in water, and that H goes and hooks up with a water molecule to make H3O. All right, POH is the negative logarithm of the hydroxide ion concentration. Formula, POH equals negative log of OH. Okay, let's practice using the log button on the calculators before we get to a real problem. So just real quickly, let's say we had something with a concentration, an H3O concentration of 3.00 times 10 to the negative 2. So how do you put this in your calculator? Unfortunately, it's going to depend on your calculator. For some of you, you will put it in your calculator exactly like the equation. pH equals, so you would put in a negative, use your negative button, and then look for your log button, which for a few of you will be a shift key, but for most of you not. And then you would put in 3.00 and your EXP or EE button, negative 2 equals. Okay? And that gave me an answer of 1.52287 and so forth. Now, if you did not get that answer, or if you got something like syntax error, we're going to have to try putting it in your calculator a little bit differently. So if you did not get the answer 1.52287, or if you got syntax error or something, putting things in your calculator this way, then you're going to need to put it in your calculator completely backwards. You'll start with putting in the concentration of the H or the H3O. Then you'll put in the log button, and then you'll put in the negative sign. So when you put yours in your calculator, it would look something like this. 3.00, your EXP or EE button. Then you would put in 2 as our exponent and then a negative. Then your log button and then your negative. And then hopefully you'll get the answer 1.52287 and so forth and so forth and so forth. So hopefully one of those two ways got you to be able to use your log button. I'm going to suspect that for most of you, this is what you'll use. Now let's try a real problem. Okay, so here's our sample problem. You have a solution with an H3O concentration of 4.56 times 10 to the negative 9th. what are the concentrations of OH, pH, or of OH, and what are the pH and pOH. What I normally do is write a data table. So I'll start with the concentration of H3O. And then I'll have the concentration of OH. And then I'll have the pH, pOH, and the last column, is this thing an acid, a base, or neutral? And from there, let's plug in what we know. We know that our H3O is 4.56 times 10 to the negative 9th. So what formula do we have that has H3O in it that can give us either OH, pH, pOH, or whether it's an acid, base, or neutral? How about H3O times OH gives us 1 times 10 to the negative 14. We were given H3O. We'll solve for OH, so we'll get some information. So we'll use concentration of H3O times concentration of OH gives us 1 times 10 to the negative 14th. We know concentration of H3O, which is 4.56 times 10 to the negative 9th. We want to determine the concentration of OH. So now let's solve for OH by dividing 1 times 10 to the negative 14th by 4.56 times 10 to the negative 9th. And that gave me 2.19 sig figs times 10 to the negative 6. 2.19 times 10 to the negative 6th. So now we know concentration of H3O, concentration of OH. We still need to solve for pH and pOH. So do we have any equations that have H3O or OH in it that allow us to solve for pH or pOH? Well, how about this guy here? pH equals negative log concentration of H plus, or concentration of H3O. So pH equals negative log concentration of H3O. So pH equals negative log of 4.56 times 10 to the negative 9th, which gives us 8.34 because of sig figs. So our pH is 8.34. Now let's see if we can solve for pOH. To calculate pOH, we can use pOH equals negative log concentration OH, and we do have that information. So pH, nope, try that again. pOH equals negative log concentration of OH. So pOH equals negative log of 2.19 times 10 to the negative 6th, which gives us 5.66, accounting for sig figs. Okay, the last thing we need to figure out is if our solution is acid, base, or neutral. How do we do that? We're going to be using the pH scale, pH. Something with a pH of 7 is neutral. Acidic is going to be something less than 7. Basic is going to be something greater than 7. Remember, though, we're talking about pH. So let's look back at our problem. And our pH is 8.34, which is greater than 7, which means that our solution is basic. Okay, that's really all there is to doing pH calculations. For each problem, you'll be given some information, the H3O or the OH for today, and you can calculate the rest. All right, that's it for today. Have a good one.